It has been a great honor and a privilege to work with Emory at Stanford, at the Doerr School of Sustainability, and at the Precourt Institute for Energy to elevate energy efficiency and literacy. He is truly a national treasure, 国宝. It is also a great pleasure, Emory, to accompany you to Taiwan, my home country, to celebrate Bruce's founding of Delta Electronics 55 years ago. In reflection, I think national treasure is perhaps an understatement. Emory, you're a treasure of planet Earth. 地球之宝. Emory, thank you for all you do. 能源是世界最大的连接系统 （connected system）。全球3%的碳排放来自于能源的转换跟能源的使用。提升能源效率是 lowest hanging fruit。实际上 ，Emory 最近提醒我 ，is not the lowest hanging fruit。这个果实已经掉到地上了，呀，给我们捡。Reflecting from your keynote, Emory, I just want to share my learnings. First, go back to the basics.
It goes back faster than we can hardly.
That's right. So first, go back to the basics. Second, connect the dots, break down the silos. And third and finally, work backward from the solution that we want. I think these are the essence of integrative design. So thank you, Emory, for that keynote. 我非常高兴看到台达跟台湾对永续发展的贡献，为了世界其他地方立树了这个耀眼的北极星 North Star。但是让我们稍微 take a moment and ask the question, what are we sustaining? 我们是在永续环境 sustaining environment， 我们是在永续经济的成长 economic growth， 也是在永续稳定 sustain stability。在这个3个方向，最重要的关键字是什么？ I think the key word here is the word and， 缺一不可。这个3个 dimension。In energy and sustainability, we are at a major inflection point. 从 green buildings and integrative design 到今天讨论的 AI data center, energy optimization， 我们现在正在见证一个能源系统的 redesign and 转变。刚刚 Emory 的 keynote 给我们了很多的 inspiration。那接下来我也很期待听到台达的 journey， 台达的 learnings, perspectives, and outlooks. Founder Bruce， 您在20年前看了 Emory 所写的《Natural Capitalism》，之后做了一连串的决策，让台达成为绿建筑跟 sustainability 的旗手。您觉得台达之所以能够顺利推荐绿建筑、推荐 energy efficiency， 主要的关键在哪里？未来还有什么样的挑战？
在台达50多年来了，我们是到后面大概是2000年左右，我们才开始做绿建筑。那做下来以后呢，这个我是发现，每次要盖一个绿建筑的话，是主要是利用 因为一般建筑就是它用这个基本的原理把它做得最好。可是我发现，我每次做绿建筑的时候，建筑师都到现场去看，同时收集了当地这个温度了，还有风了各方面的经验来设计。这样子做下来的话呢，真的是做得非常有效果。我们是一刚开始我们还是用一般的建筑。我们在台南厂的时候呢，因为就是看到这个 Dr. Lovins 的那本书《绿色资本主义》，我们在台湾把它翻译成《绿色资本主义》。我看了以后，觉得有很多事情去试试看，的确是很有用。还有呢，我还要讲呢，我们一刚开始在创业的时候呢，我们是做 coil 线圈，那么到做了一段时间以后，我觉得这个竞争也越来越厉害。可是另外一件事情的话呢，在做电视的时候，我就去尝试一下电视的线路，那它效率就比 power supply 要高很多。那个时候大家所用的是 linear power supply。linear power supply 的话，就是从60 cycle 的电源来变成这个线路上需要的很低的几伏特、1、2伏特，这个 chips 都是比较低的支流，那效率非常低，在这样的做下来的很低。那我就在觉得说，为什么电视的其他的线路，因为电视其他的线路像对用到 Macros 很高的频率，而 Power Supply 的话呢，还是之前用60 cycle， 因此我就在想呢，要把怎么样能够把 Power Supply， 当时的 Power Supply 大概只有50多，最好的也不过是65% efficiency。换句话说，你有用的大部分这个其他的65% 的话，即使是65%，你是其他的呢就变成热，这个里头就发热。那有没有办法把它做得更高？当时就在想呢，这个电视的线路它是用 Macros， 它的 efficiency， 而且每一代越来越频率越高，频率在改善的时候，效率就越来越高。我就很想呢，把 power supply 这个也把它弄高。那就觉得这两个东西差别在哪里？差别一个是直接用60 cycle 来变，另外的话呢，它是用高频率来做。因此，我就在想呢，我们不能够直接用60 cycle 来做出最后所需要的低的 DC 的电压，要想办法呢，把这个 power supply 效率也把它提高。所以就是后面所讲的 switching power supply， 就做这种设计。那么那个时候大概250个 kilohertz， 效率就高很多。一路做下来，很多人就说你搞这个新的东西，你希望能够做到效率多少？我说我也不知道，我只是尝试。那个我希望将来可以变成90% 的 efficiency， 就是说你多少能量进去，90%都是有用的。那结果做了几年以后，我们还超过90% efficiency， 也就是因为 做这个改变，这个对公司的这个生意就增加很多。所以在另外呢，从 Dr. Levins 去了解的话呢，又有很多新的想法。他比如说，他告诉我说，你为什么一个输电线输的，比如说是不管是流体的什么，你转个90度，转个90度，你的这个马达就要每转个90度，你就增加了1倍以上的这个电能，所以把管子用的越粗啊，用的更粗，而且呢，尽量走直线。你要弯的时候，你也不能够是这样子弯，你把它弯的大一点，就是说不会。这个有很多的技术不断的去改善啊，都是真正的有用。所以我就觉得他当时写这本书的时候呢，都有一些实际的例子，我就去尝试看看，这个可以用得上的尽量用上。对于 power supply， 后面做到现在可以做到97、98这个 percent， 我还在问工程师，你还有没有办法再增高？的确是很难，可是他告诉我说，将来也许做的最好的，可以有机会做到99%的，这是我们的工程师自己讲的。所以说，只要不断的对一个科技，你给他做一些目标，就朝这个方面去想各种办法，最后就可以得到好的效果。也是今天台达在这个对台达来说，生意会还不错的话呢，是这种想法。每个人都在想，我们要怎么做得更好，做得更好以后，还希望说还要更好，从不放弃的这种做法。
Thank you so much, Bruce. I just realized something. Both you and Emery are amazing storytellers. And for complex topics like sustainability, storytelling of successful example is absolutely essential. So Bruce, thank you for sharing Delta's journey and how we got here. 那接下来呢，我想从这个 past to future， 我想问郑平董事长，我们把这个话题带到 AI 跟这个 AI 的能源的需求。现在全世界都关注于 AI 的用电需求。那刚刚 Emery 也提到了，关心这个 data center 用电的挑战。他最近也发表了这个 publication 提醒这个用天然气所造成的 CO2 emission。台达在全球的这个 AI 的 supply chain 有非常重要的角色，是不是请您分享一下台达的 perspective， 尤其怎么看待这个 AI 的发展跟能源需求的议题？
好，我台达现在的这个电与就是电的方案，还有那个散热的方案，大部分是在 data center 的所谓 white space， 就是 data center 内部哈。那这边我们希望我们各个产品或者这个 component， 它的效率很高。那我们也一直致力在这个转换的次数哈。假设这个转换次数能够减低的话，那这个整个的整体系统的效率还可以持续提升。好，所以不光是单的元器件的效率，而且看到整个 solution 它的整体的效率。那现在我们其实也在发展这个到所谓灰区，好 gray space 这边，整个这个 data center， 尤其现在 data center 用电量，而且这种大型的 data center 用电量非常大，所以实际上它大概如果跟城市的这个 microgrid 混合的话，它可能复杂性更高。所以我们现在也看到未来有这个所谓 island 型的这种data center 的整个 microgrid 的这个 solution， 那里面就含了很多啊，包含这个储能啊，包含也是一样，就从高压或者从这个交流转直流哈，高压转低压，这里面我们都希望能够把这个转换次数能够降低。那再来，因为传输的距离也是一个很大的能量损耗，所以将来这种所谓的分散式的发电哈，也会越来越多，所以我们也发展这个所谓的这个fuel cell 哈，这燃料电池。那我们也几年前我们发现一个燃料电池的技术，就是它的能源转换效率可以达到65%，如果再加上热回收的话，甚至可以达到80%。各位知道这个 gas turbine 这种发电大概转换效率大概在35%，所以如果在发电端有更好的这种发电模式哈，那可以提升这个效率的话，那整体从发输配好这边，实际上整个的管理这个整个的效率，我认为还有非常大的这个提升的空间。好，台达现在是这个Coalition for Sustainable AI 的成员哈，所以我们也非常期望能够跟我们的整个策略这些 business 的伙伴们好一起来合作哈，一起来发展这些 solution。
Ping, thank you so much. I completely agree that by integration of generation, transmission, storage, and utilization around data center, that presents a huge opportunity to tap efficiency, as Emery puts it, the most underestimated energy resource. So thank you for sharing that. We'll come back to this important topic in a few minutes. Let me now turn to Yancy 来请教海先生。现在全世界面临的很多的不确定性，尤其是在能源这一块。去年10月我们在 Stanford 与您跟 Emery 交谈的时候，您提到了这个现在世界面临很多的这个 Black Swan 黑天鹅的 event， 但是我没有想到短短半年之后我们相见，哇，这个企业面对的挑战又更大了。这个不管是 ESG 的 headwind， 或是现在面临的 energy security， 您现在有什么建议给台下的这些企业家还有决策者？
好，我有谢谢。我想在回答这个问题之前呢，我要回顾一下那个台达啊，跟这个 Rocky Mountain Institute 啊，跟这个 Dr. Lovins 啊，过去一些这个渊源吧，啊，因为今天请 Dr. Lovins 来，我们也是这个真的谢谢他啊，给台达很多启发啊。刚刚我就为什么想先讲这个呢？就是刚刚这个阙教授啊，他说，哎，你们台达啊，怎么要去做这些事情啊？这个 Dr. Lovins 在 Natural Capitalism 里面讲的这些东西啊，我想。那个大小的 Dr. Lovins 啊，他是那个 Rocky Mountain Institute 他的这个创办人啊，你看很多人都说啊，那 IMI 啊，就是 Rocky Mountain Institute 啊，是不是怎么一个 think tank？ 他一听到 think tank 他就很生气，他说我不只是 think， 我是 think and do， 那讲到台达啊，我就讲一个故事。他说要讲故事嘛，对不对？那我要讲故事。那郑先生呢？就我们看了这个 Dr. Lovins 的书啊，他尤其他对那个绿建筑啊，这个很有兴趣啊。那普通人看看也就罢了，对不对？那里面啊，这个 Dr. Lovins 提了泰国啊那个朱拉农工大学一个教授建筑系教授啊，他盖了一个绿建筑。那这一看，哎，既然有。我们去看呐，那这些说做就做啊，所以呢，我们看了书之后，大概就几个月之后，这个人说，对，我们去看啊，这些就带着我们来 就去泰国去看啊。那这个绿建筑呢是个房子，还不是这个 office 啊。但绿建筑呢很有意思啊，因为泰国很热啊，所以跟那个Dr. Lovins 在那个 Rocky Mountain 的那个 office 跟他家完全那个气候形态完全不一样。那他们那边是要这个保暖啊，那泰国呢是要降温呐，泰国又热又湿啊，那怎么办啊？所以呢，他两个事情我到现在已经看了20多年了吧哈，那个我还印象深刻。第一个啊，就是它的这个冷气啊，不是用我们这个窗型啊，或者是中央冷气啊，它旁边有一个房子旁边有一个那个游泳池啊，它的用游泳池的水啊，然后呢，在它的房子里面做了 pipe 啊，就跟我们现在我们这个叫加州Fremont 那个 office 啊，那个它 cooling 啊，那个道理是一样的，它是用水的这个温度来降温啊，所以呢，它那个当然它那时候也装了一些太阳能板啊什么东西，但是那时候太阳能板它的效率还不是那么高，所以那个效果并不是那么大啊。另外一个呢很有意思的就是说，它有个院子啊，那院子上面有一些小山啊什么的，那我们说那个你这些landscaping 做得很好，他说这不是只是给你好看的啊，我这个呢这个小山是来导风的啊。他说，所以箴言讲说每一次我们盖房子都要建筑师到那个当地去看看，你风怎么吹啊，什么你这个温度啊、湿度啊等等啊。他说呢，他那个小山就是来导风的所以把这个外面的风导进来。然后他还跟我们讲说，这就是你们中国的风水有风它那个才有这个好的空气。不过回到那个这个 Will 讲的这个黑天鹅这个问题，还有这个 ESG 这个 headwind 这 headwind 大家晓得吗？就是这个我们川普大帝对 ESG 不喜欢他说ESG 说了那个 dirty words 那就都不要讲但是我说从这个企业的角度来说，假如我节能的话，你说我不该做吗？就是应该节省那假如说我不讲ESG你不讲这个东西，那我做总是可以吧？那你企业你本来就是要 efficient 那企业的责任大家说企业责任是什么？当然要第一个就是股东的这个报酬那当然还有对社会的这个责任，这都是企业的责任企业该做的事所以我那个黑天鹅会继续出来但是呢，我想企业还是做好自己的事情那这个希望大家这个记住谢谢。
严信，您上次在 Stanford 的时候也给我们了一句名言 ，Just do it 。Thank you so much. So there are a number of questions from the audience, and including some of my own. So Emery, many of these are for you, but also for the rest of the panel as well. We are running a little low on time, so let me maybe ask everyone to be brief in their remarks. The first question, Emery, is a fun one. So you showed photos of your home in Old Mass, Snowmass, and it does not have cooling or heating. Yet it is comfortable when the outside temperature drops below minus 40 degrees Celsius, 零下40度. And it was constructed more than 40 years ago in 1983. And you have hosted many visitors over the years. What? 200,000 visitors. All right, now I'm going to ask a really tough question. What were some of the most surprising questions and comments you have received?
The house cost less to build, as I've explained, without a heating system. And then we took that saving plus a little more. Today it would be about $10,000 to save also about 99% of the water heating energy, 90% of the electricity, and half the water. And all of those together with the 99% saving on space heat paid back in about 10 months. Today you could do much better. But it's amazing how many visitors who have an MBA degree and are senior corporate executives say about the reduced construction cost without heat. So what's the payback? And I said, no, it costs less to build. They said, but what's the payback? And I said, what part of costs less to build don't you understand? This is a very common event because somehow they were brainwashed in business school into thinking that more efficiency always costs more, that it's diminishing returns. Well, yes, until you get to the point where you don't need the heating system anymore, so you save its capital cost. And it costs slightly less to build using 99% less heat before we count the value of not needing the heat. But the optimization method in all the textbooks leaves out the capital cost of the heating equipment. Just like in sizing the pipe, they leave out the capital cost of the pumping equipment. Standard mistake, very, very common.
Emery, I just want to note that while many of the public conversations around sustainability has focused on the green premium, what you articulate is the green value. And this is really critical.
Exactly. So you often hear that protecting the climate will cost more. Well, in energy, there are two main parts of it. You save energy, that's cheaper than buying it, and you use renewable energy, which is cheaper than fuels. Well, I was taught in school if A plus B equals C, and A and B both get smaller, then C will also get smaller. So this is a sign error. They're confusing a plus and a minus sign. Protecting the climate is not costly, it is profitable.
And this is something that Ping had commented on earlier. From power generation to data centers to chips inside the data center, it's all part of a giant system. Innovation is moving very, very quickly inside data centers. But outside, there's also a major opportunity for innovation to accelerate the progress. How can we use the growing electricity demand as a catalyst to build a next generation of power system outside the data center, whether it's storage or grid, rather than building out one of the same that we have today? Emery, love to have your take on this.
Well, AI developers are much more interested in speed to market than in cost. And already when some of them wanted to buy gas-fired, in your case it would be LNG-fired power plants, they found that the turbine market and some other major components are already sold out into the early 2030s. So they cannot get speed in that way. And somewhat reluctantly, they're coming back to what was the best solution in the first place, renewables, along with efficient use. My main concern here is with the enormous uncertainty of demand for AI electricity, because the AI enterprise itself has yet to show enough revenue to pay for its investments, especially when they depreciate so fast. But also, we know that there's about 1 million-fold efficiency potential in converting electricity to AI tokens. We're about halfway through that. And then there's another 3 to 7 orders of magnitude gain if we go to optical chips. So the uncertainty in the next decade or so in AI electric demand is very large. It's at least a factor 8. And this raises a big question. How do you manage the risk of such uncertainty and not build pre-stranded assets? Well, one way is to build very fast renewable pop-up power supplies, like the 4-month example I showed. It takes about 18 to 30 months to build a data center. If it takes only 4 months to build the power supply, you can build it later and be less at risk. And then the power supplier should sell the power on a take-or-pay contract backed by a surety bond or insurance policy, so that if the data center is not built or does not thrive for long enough to pay for the investment in power, it does not harm the other customers.
Delta, Ping just mentioned, okay, mainly in the past, okay, we're in the white space. Okay. Then now, Delta, we have this new slogan called the from chips to grid. So that's why, other than making power supply more efficient, Delta is also developing, Ping just mentioned, say like a fuel cell and power storage, and also some power conditioning systems. If we, now back to Emery's point, you need to look at this at on the system level. You don't look at only the component level. If you look at the component level, even Bruce mentioned, even our power supply now reach 99%, right? But still, if you're outside, your transmission is only, I don't know, 50%. You still have a lot of room for improvement. So for now, I think that the one urgent task is for the utility companies and for equipment manufacturers and the data centers work together as a team. And now the utilities, they are focusing on their, say, own grid. And then, say, Delta or other companies like Vertiv looking at the white space. So we need to look at the system from end to end.
Thank you very much, Yancy. I see that the sign is popping up that we're out of time, but there's one more question, if I can be permitted, Wim, to ask. We have made a lot of progress on energy efficiency over the past half a century, thanks to Emery, Bruce, the Delta team. Let's take a moment maybe to close this panel to look beyond energy and look at resources more broadly, whether it's water or minerals. How can we apply integrative design to these highly traditional and conservative sectors? 如果我们把我们的这个眼光超越能源，放在更广泛的这些区域，像水资源跟矿产资源，我们如何用这个 integrative design 的模式来影响这些传统的产业？Anyone would like to have a take on this?
There is an equally powerful story for efficiency in using water and minerals of all kinds, and I've pursued this for decades as well. But I think maybe what we also need is a new business model. Where do you suppose is the biggest high-grade copper deposit in the world? Is it Zambia, Chile, Congo? Well, actually, it's under the streets of Manhattan in New York. It's all the signal and especially power wires that were copper that was mined, sold by the ton to the wire company, sold to the power or telecoms company, and buried not very retrievably. But suppose instead we had a different business model and companies would lease the conductance services of the copper. Instead of selling tons of copper, lease the services they give you. So the more service you deliver with less copper, the more money you and the customer both make. So now the provider and customer interests can be aligned, and the R&D of the copper company will focus on wireless and fiber optics to free up copper to lease to someone else. We can do the same thing with cement. What if instead of selling tons of cement, we lease the structural service, say, of a bridge, and we get paid for how many people move safely and efficiently across the bridge. But then we build an airy dendritic bridge, like I showed in the picture, that holds up mainly the payload, not itself, because that's a more profitable thing to do. In other words, in a world that is using all resources more productively, don't sell tons of stuff, lease the services we want from the stuff. And I think that will better align interests and drive efficiency much faster.
Thank you very much, Emery, for that. Ending on this really powerful note, I would like to thank everyone, of course, Emery and Bruce, for your friendship that catalyzed today's conversation, Yancy and Ping for leading Delta, enabling Taiwan to be a world leader in energy efficiency. So please join me in thanking everyone. Thank you so much.